to, which you see on the screen, and we were doing two things. We were doing tangent line and we were doing particular solution. So if we're going to do the tangent line, easy enough, your point is given, your slope is found by using the derivative, also given. So if we plug in 0, 5, you're going to get 6 minus 5 is 1, sine is 0 is 0, should be giving you 0 for your slope. Tangent line would then be y minus 5 is equal to 0x minus 0. Y equals 5 would be your tangent line. And did they ask us to plug anything in? No. Okay, so that's the end of it. And then for part B, that's your differential equation stuff. So we would start by splitting the variables. So that's 1 over 6 minus y dy is equal to the integral of sine x dx. And we want to say, how do we integrate both sides? On the left, you would need u substitution. On the right side, that's just going to be regular integration. So we're going to go u du dy. So 6 minus y, negative dy, negative du. Plugging that in is negative symbol, integral 1 over u du is equal to the integral of sine x dx. Do we have any questions up to that point prior to integrating? So hopefully by this time, you're starting to get very familiar with this. It's very repetitive. That's a good thing. So you should say it's negative natural log absolute value of 6 minus y is equal to negative cosine x plus c. From there, we want to plug in and solve for c, and we have the point 0, 5. So this is negative natural log of 1, because that's 6 minus 5, is equal to negative cosine 0 plus c. So that's 0 natural log of 1 is equal to negative 1. Cosine of 0 is 1 with a negative sign in front of it. Solving for c, you come up with 1. And then we want to go plug that in. So then if we go over and do that, now you have negative natural log of 6 minus y is equal to negative cosine x plus 1. Divide both sides by negative 1, and I've got natural log of 6 minus y is equal to cosine x minus 1. Next up, we're going to rewrite this so that we can unlock y as a logarithm in base e of 6 minus y log base answer exponent. Solving for y, we're going to toss y on the left side, and y would be equal to 6 minus e raised to the cosine x minus 1. Does anybody have any questions on the first free response? Okay. All right, let's see what else we had on this packet. Next up, we had the graph questions. Let me share my screen. Okay, we're looking at the graph. It says it's the graph of f. So we're looking at the graph of f, and we have a function given down below. It says that g of x is equal to the integral of f of t dt from -3 to x. All right, so that's what we're going to be basing all the things in our question of. So if I find g of 5 in part A, first thing you'd want to do is write that g of 5 is equal to -3 to 5, -3 to 5. So f of t dt, that's the graph we have. That just means to find the areas of what you have up here from -3 to 5. So that's 8 by 4 is 32, cut in half for triangles. Part A is 16. Part B, on what open intervals is the graph both increasing and concave down, increasing and concave down. But now what's the key word? The graph of G is what they're asking. Well, we have the graph of F. So the first statement you need to make is what, somebody?
G prime of x is equal to f of x.
Perfect. So we want to say that G prime is equal to F. And now we're going to treat this as the derivative graph of G, which means I'm looking for it to be above with a negative slope. And that's happening from 0 to 5. So the graph of G is, what do they want? Increasing and concave down on 0 to 5 because what?
Because G prime is both positive and decreasing on that interval.
It's positive and decreasing. Perfect. So if that makes sense, you have got all the points for A and B. Takes you to C. Where is there a relative max? For the same exact reasoning we just talked about in B, G prime of x is equal to F. And there's a relative max at x equals 5 because G prime of x changes from positive to negative. Okay. Should all sound familiar. Takes us to part D. H prime, that should be a quotient rule. So H prime of x is equal to bottom, derive the top, minus the top, derive the bottom, over the bottom squared. And into that, we are going to plug in 5. So we've got 15 G prime of 5 minus G of 5 you found in part A, that was 16 times 3 over, what are we plugging in? 5 over 225, that's 15 squared. G prime of 5, how do we find G prime of 5?
Since G prime of 5 is equal to f of x, or G prime is equal to f of x, you find where 5 is on f of x.
So G prime is equal to
0.
F, so it should just be 0, right? So this piece right here is just 0, and you can leave that as your answer, or if you go further, you could go and do some math, but it's free response. So you could leave it as 15 times 0 minus 16 times 3 over 225. Okay, good. Takes us to number 3. Part A, if you're approximating 3.5, the slope of it, C prime, shouldn't even need me to write this out. For C prime of 3.5, you're just doing the slopes. So for part A, you would say that C prime of 3.5 is approximately equal to, what are we going to do? The Y values, 12.8 minus 11.2 over 4 minus 3 gives us 1.6 ounces per minute squared. Letter B, is there a time where C prime of t is equal to 2 and we're using the interval 2 to 4? This is mean value theorem. Yes, because the function is, because the function's what? Differentiable and therefore continuous by the mean value theorem, there must be a time where C, what did I say? C prime of t is equal to 2 because, and then we're just going to show the slopes, because what? 12.8 minus 11.2 over 3 minus 4. Did I do the wrong ones? Hold on. I had the wrong one. 4 and 2. This is not 11.2. That's 8.8. And then that's 4 minus 2. sorry, I was looking at A, is equal to, what's that give you? 4 over 2 g equals 2. Do we have any questions on B?
Why is it?
Well, I still read that backwards. It's 4 minus 2 down there. Was that your question?
Yeah, just
Yeah, I wrote it backwards. Sorry.
yeah, no. I'm also just wondering, why is it yes? Like,
Why is it yes?
yeah, just like, how do you tell again?
The question says, is there a time where the tangent slope is equal to 2? And I'm showing you that the secant slope is 2. So if the secant slope is 2 and the thing's differentiable and continuous, the mean value theorem says there has to be a spot where the tangent slope is 2. So what that question is saying in English is, here's your fake curve. It says on the interval 2 to 4, is there a time where the tangent slope's 2? So all you're doing is showing that that regular secant slope, it's 2. That's what we just showed over here. So if that regular slope is 2, what's the mean value theorem problem tell me? Somewhere on this interval is a tangent slope that's also 2. So go back to read that question again. Now it says, is there a time where the tangent slope is 2? We go, I don't know. But we look at the endpoints they give me, and we find that the average rate of change, that secant slope to be 2. And then you say, oh, okay, we're good. Because the function's differentiable and continuous, the mean value theorem says there's got to be a time where that tangent slope is 2. And then that's kind of the end of the problem. Does that make sense?
Yeah, thank you.
Okay. All right, C, we're going to kind of avoid the math on that. There's no midpoint sum on your test now. They're all left, right, whatever. But let's just read it. And we want to understand the meaning of this. So the thing with the fraction in front is average value. What are we talking about? Average temperature. So 1 over 6, integral 0 to 6 CT dt stands for the average temperature. What are we talking about here? The coffee. Is this temperature or not? Hold on. I need to read the problem. Average ounces in the coffee maker over the interval 0 to 6. And then you would have used a Riemann sum of some sort and then multiplied it by 1/6 when you're done to come up with an answer. Okay. And the last one, D, the amount of coffee in a cup is that. We want to find the rate at which the coffee in the cup is changing at 5. Translation, find B prime of 5. The rate at which something's changing is the derivative. So you would find B prime of 5. So how do we do that? B prime of T is equal to, all right, first off, that 16's out of there. And then we have now negative 16 e to the negative 0.4 t. So we're taking a derivative involving e to the stuff. The derivative involving e to the stuff is e to the stuff. So let's just rewrite the problem. Times stuff prime. Stuff prime would be negative 0.4. And then if we tried to clean that up, a negative times a negative is a positive. And then what is 0.4 times 16? That would be 6.4 e to the negative 0.4 t. So that's B prime of t. Okay. How did I get this, in case you're wondering? 0.4 stands for 40%, because this actually is a non-calculator question. 0.4 stands for 40%. So let's find 10% first. 10% of 16 is 1.6. So if 10% is 1.6, take that times 4. You actually would have had to do that in your head. Take that times 4, and that's 6.4. Kind of compare it like 16 and 64. I'm just doing 1.6 and 6.4. Okay, now that we have a derivative, I'm going to go B prime of 5, and that's just going to be 6.4 e to the negative. If we put a 5 in there, 5 times 0.4, that's like 2/5 of 5. You got to do some math now. That's going to be what? Are we good with negative 2? So cleaning that up, I'm going to call this 6.4 over e squared for a final answer. Comments, questions, thoughts? Okay. All right, moving along. Next one. Find all the x coordinates where we have a relative max. We're looking at the derivative graph, nice and easy now. This question used to be hard. Now you're going to buzz through it. That would happen at -2. So I'm not going to write all that out, but there would be a relative max at x equals -2 because f prime of x changes from positive to negative. B, on what open intervals is the graph both concave down and decreasing? That's this negative slope and below the x. So we're looking at from -2 to -1 and from 1 to 3 because f prime of x is decreasing and negative. How about C? We're looking at points of inflection. So if we're looking at points of inflection for C, right? That's the turning point of the derivative graph. You want to group your answers accordingly. So you should be answering it with the -1 and 3 as one answer and +1 as the other. And your answers are because f prime changes from decreasing to increasing for the groups of 2 of them. And for the 1, it would be from increasing to decreasing. Okay. So does anybody have any questions on A or B or C? All right. Then let's take a look at D. Given that f of 1 is equal to 3, find us an expression for f of x and find f of 4. This is now hopefully much more obvious to you after doing particle motion and other stuff that this is an FTC question. So first thing we want to do is write the expression for f of x. So for D, we're going to say that the integral of f prime of x dx from a bound I know, which is 1, and a bound I want, which is 4, is equal to f of 4 minus f of 1. F of 1 is 3. So that's f of 4 minus 3. Integral of f prime of x dx from 1 to 4. All right, we need to solve for something. So what are we solving for? We're solving for f of 4. So let's get that 3 out of there. So that's 3 plus 1 to 4 f prime of x dx is equal to f of 4. All right, next. What are we doing? We need to do that actual integral. So we go up and say, well, wait, we have the graph of f prime. So let's go investigate. And we're looking for that area from 1 to 4. So to find that area from 1 to 4, we've got options. What are the options? You say, do we have an equation? No. Is this something I can do with geometry shapes? No. If those two answers are no, they need to just tell you or you're in trouble. And then you go to the opening paragraph and you say, okay, they do tell me. So the areas, they give us 2 of them. They give us this one and they give us this one. And they say they're 9 and 12 respectively. So the one we're interested in is 12, but since we're underground, we're going to make it -12. So the integral that I'm interested in for that is -12. Do a little math, and we should be getting -9. Do we have any questions there? Okay, so if these are all checking out, I think we're doing really good. One more to go, and that's particle motion. Now, this was a calculator question, so you need your calculator to do that. We will just be talking about the plan for each problem, and then I'll have you guys give me some answers. So the first one is the particle speeding up or slowing down. For part A, the plan is we're going to find V of 4 and A of 4. So for part A, somebody that did this, tell me about V of 4 and A of 4. What do we got?
For A of 4, I forget exactly what it was, but I had a negative.
And how about V of 4?
Positive.
So is it speeding up or slowing down?
It's slowing down.
Okay, so it would be slowing down because V of 4 is greater than 0 and A of 4 is less than 0, and you could have shown those actual numbers to get credit. Okay, good. All right, B, find all the intervals or all the times in the intervals 0 to 3 where the thing changes directions. First thing you should do is change your interval to 0 to 3, and then figure out where the graph crosses the x-axis. So you would graph it and find the zeros. Just make sure you're only finding them from 0 to 3. Where did this cross at?
I got 2.707.
Yep, at 2.707 because V prime, or because via t, excuse me, via t changes from, and then which way did it cross, Lila? Was it above to below or below?
Positive to negative.
All right, because it changes from positive to negative. Good. Okay, C, how do we find the position? To find position at t equals 0, this is your FTC problem. We need to integrate via t dt from, we want it at 0, and which one are we given? We're given time equals 4, right? Remember, these are time values in the top. So integrate that, and that's going to give me x of 4 minus x of 0. What do we know about x of 4? Up above, they tell me in the directions that that is 2. So x of 4 is really 2. Okay, we're solving for x of 0, so I'm going to move that to the left. So x of 0 is equal to 2 minus integral 0 to 4 via t dt. You now need to go in the calculator and figure out that integral and then do 2 minus whatever you get. What did you get when you did that?
I got that the integral was 5.815, so that means that x of 0 is negative 3.815.
Sounds good to me. And find the total distance traveled. If we're going to do total distance traveled for part D, we should have that memorized by now. It's the absolute value of via t dt. And they said from 0 to 3. So those are the bounds you're going with. Toss it into a calculator. Remember to get absolute value. It's math. Scroll over to num, N-U-M, and ABS is your absolute value. So that's nothing more than just firing it into a calculator, and somebody tell me what we got for that one.
4.972.
4.972.
I got 5.301. I might have done.
Did you do absolute value?
Yeah, let me check again.
Syed, did you do absolute value?
No, she might be right. I didn't.
All right, try to get
No, I got the same thing Syed did.
4.972.
Yeah.
Try again, Caroline, see if you get it.
I still got the same thing.
You in radian mode?
Yep. Let me make sure I put the numbers in correctly. Oh, dude, I can't scroll. 3 to 0, right?
Zero's on the bottom, right?
Yep.
Mhm.
And then 1 plus 2 sine x squared divided by 2. With absolute value signs on either side.
You got the same thing?
Yep.
All
I
right.
put like
All
I
right,
did
all right,
the
all right.
multiplication sign next to the 2. Maybe that messed it up.
I don't think. Let me see. That shouldn't change.
Mr. Baker, I get the exact same thing that Caroline got.
All right. Opening up the calculator here. I'll play tiebreaker. Let's see what we get. doing something here. Where's that file at? Okay. Wait, did I agree? Go to Ron, I did. Okay, there we go. All right, so we need to be in radian mode. I am. And now I'm going to do math 9, 0 to 3. What's the formula, Caroline? Read it.
1 plus 2 sine, and then in parentheses,
Victor,
x
don't forget your
squared
absolute
divided by
value.
2. Oh, but the absolute value
Yeah, okay. X squared
divided by 2.
divided by 2. We need to get this whole thing into absolute value symbols. Can I do that still? Second. Nah, I screwed up. Let's just start again. Math 9, 0 to 3. Total distance traveled. So math num ABS. All right, 1 plus 2 sine. Oop, too many signs. Hold on, I don't like that that's there.
That will be there until you end the
Oh,
parentheses.
is that what it is? Okay, what's the angle?
X squared divided by 2.
Wait, Caroline, what did you get?
5.301.
Okay, I got that. I forgot the absolute value.
All right, let's see. D what? D X. All right, we're going to go with 5.301. So it sounds like if you had 4.9, you just needed to do some absolute value symbols. But either way, you guys are doing very good with all of that. So do we have any questions on any of those 5 problems you just saw? I mean, we just went over 5 pretty solid free response problems in like a half hour. And I'm here to tell you, you're allowed to have 75 minutes to talk about them and go over them and do them. So if you're understanding all of that in a half an hour, you are way above and beyond what is necessary for the AP exam. So we still got more to learn and more to do, but I'd say you're more than on schedule to be passing this in a couple of months. Any questions? All right, guys, we'll call it a day. Let me scribble your names down here real quick and then we'll be out of here. All right, guys, got it. We will start with something new tomorrow. So I will see you guys tomorrow and have a good night.
Thank you. Have a great day.